This is a video to show how we're going to make gears in Inventor for 3D printing. We open up an assembly. You going to click on design. You're going to click on spur gears. You get this list here. 1.5, the module is strong enough to, with a 10mm face width, to pick up a robot. Here you have the ratio 19 to 30 we picked. You can pick pretty much anything that will give you that is necessary for your needs. Let's go look at the preview. This is how it's going to look. The addendum here, the bigger it is, the longer the teeth are. That both have short and long teeth have advantages, disadvantages. Short teeth are stronger, long gears are more forgiving if you have some incorrectness when you mount them and some deflection in the axle. So 30-degree helix angle, that's the best helix angle for 3D printed gear, and 14.5-degree pressure angle. 19 is about at the lowest limits that we can do. We will get a warning when we save that, but it's okay. I have printed many of those gears. See, we have the warning here. So we accept it and we place the gear. Now, a mistake many people make to print those gears. That is no good because those are not accurate gears. They are made just for the assembly for animation, fast to compute. If we zoom in, we see we have them overlapping in some stuff, which is fine for an animation, but in reality, this won't work. So we're only going to make the smaller gear, the pinion, because making gears, throwing all the teeth takes a long time. So we click on it. We are going to click export tooth shape. We're going to select the pinion or the gear. The pinion is the smaller one. For normal backlash, it depends on your printer and on your needs. In my case, 0.1 millimeter is very good in most cases. With a very accurate printer, you can even go like to 0.05. So we click OK, and we get this here. So to go shortly over this is all used. You have a lot of variables. You have parameters here, like the number of teeth that you can use in sketches and extrusions, and head diameter, base diameter, root diameter, pitch diameter. You can use all those variables in there. You, of course, can add a variable, like we can, let's see, add a variable that's called bore. We're going to make a hole into this gear, and let's make this 10 millimeters. The advantage of using parameters is you can change them. Let's say if you want to go from 10 to 11 millimeters, you can change them, and you can make that. So the first thing we're going to do is we're going to put a little chamfer on the outside here. Not 2 millimeter, 0.6 is enough, or 0.5. This is just for when we printed the elephant's foot, so we have to not clean up too many things when we 3D print it. That again is depending on the kind of build plate you use, and the smaller the better, basically. So we click OK, and now we're going to go make a coil. We are going to click on this cutout here. Okay, we select an axis, which is the C-axis, and it already put, because I used the same thing over and over again, Inventor's pretty smart. We see a pitch diameter times pi times tangent 60 degrees. We actually want the cotangents of 30, but the cotangents of 30 equals the tangent of 60, and Inventor doesn't have a cotangents function. To my knowledge, I have never seen it, and we make sure we click on cut here. So now we have this cut out. So now we are going to continue, make a chamfer here, which is for, did I put it in the right position? Let's do it again. I don't think so. Okay, chamfer here, here, here. That again is for, because we 3D print for, not for cleanup purposes. Now we're going to put a fillet on the top. It's called crowning the tooth. A good rule of thumb is for most printers 0.4, maybe a little bit less for 0.3 if you have a very accurate printer, plus 0.1 millimeter per module. So in this case, because the module is 1.5, it's 4.4 plus 1.5 is 0.55 millimeters fillet, which we are going to put here and here. So, and now we're going to make a circular pattern. We're going to select those 3 items for it. We select the C-axis, and we put in here, click on here, we go to list parameters, or if it's already a number of these, again it likes to, it saves stuff from prior drawings. So we click OK, and this takes a long time. This can take minutes. I will shorten the time for you by editing it out. Okay, it's finished drawing the teeth, and now we can put our bore that we have defined in. So we're going to start to the sketch here, and we make a circle, make sure it's nice centered, and we dimension, and we can again go here to, and we go to list parameters, and we can go to our bore, click OK, and there we have the circle, and we extrude it through all. So now we can mirror the whole object. We click on, because we want to make a double helical gear, we click on mirror, we click on body, we click on the XY plane, and we click OK. And there we have a double helical gear. Now all that's left is to save it. And I have one already. I name it P19 tooth 1500 HH, so it's the 19 tooth gear, 1.5 millimeter modulus, and HH is for double helical. Okay, and we are done. So that is how you make a gear in Inventor.